I recorded it from last period though, so that'll be okay. All right, let's see. Okay, so next section, 4.5, pretty simple one. Really, I'd say it's easier than 4.3 and 4.4 in a way. All we're doing here, there's one thing that we're going to show how to do, and that is we want to, if we can show using our tricks that two triangles are congruent, then we can use that fact in proofs, for example, to show that other stuff is congruent. Okay, so for example, let's take this guy right here. Okay. Suppose that we want to prove that angle PQS, so that's this angle right here, right, is congruent to angle RQS, that angle right there. Okay, that's what we want to do. We've got lots of tricky ways from all the stuff we've learned in previous chapters to show that angles are congruent. But usually we have things like vertical angles, or we can use our parallel lines are cut by a transversal. We have lots of relationships. We don't really have anything here though, do we? We don't have any tricky way to show that those angles are congruent just based on what we're given. Okay? But what we could do, we could show that the left triangle is congruent to the right triangle. And if that's the case, then think about that. If those two triangles are congruent, then doesn't that mean that all 6 parts of the left triangle, go by there, are congruent to all 6 parts of the right triangle? So then we'd know that those would have to be congruent just based on the fact that they're parts of the triangles that are congruent, right? Does that make sense for our strategy? We can't show that those angles are congruent directly, but how could we easily show that the two triangles are congruent? What third part could we add? Say it again? They share a side. Yeah, they share a side. And so side QS is congruent to itself because everything's congruent to itself, right? All congruent means the same shape and size. So if I take that segment and pick it up and set it down on top of itself, obviously it overlaps. Remember what property that is? Reflexive, yeah. Just like your reflection in the mirror. You're congruent to yourself, and you can see that in your reflection, right? So that's the reflexive property. Shows that that side is congruent to itself. Now if I pull those two triangles apart, what's going to be the pattern that shows that they're congruent? SSS, right, good. So we know then that triangle, we need a name for the left triangle. Justine, give me a name for the left triangle. You got all kinds of choices. Triangle PQS works. So triangle PQS is congruent to triangle something by SSS, right? What does the other triangle have to be called then? If I call the left one PQS, what does the right one have to be? RQS. Yeah, good. And let's talk about why that is. Right? Because we can see that angle P and angle R go together, right? We can see it for a bunch of reasons. We can see it because in the drawing it's pretty clear, but also, even if the drawing were not drawn very well, side or angle P is the one that's between the sides, the congruent sides that have 1 dash and 2 dashes, right? So we'd look for the same relationship over here. Between the sides with 1 dash and 2 dashes would be R, right? Q. Well, Q is between 1 dash and 3 dashes on both triangles. So Q has to go with Q, and that leaves us S goes with S, right? So if those triangles are congruent, then I should be able to say this. I should be able to say, okay, now angle P, whoops, not R, angle P, QS is congruent to angle RQS by what reason do you suppose we would, why is it? Just, you don't explain to me. What's kind of the reasoning there? I showed the triangles are congruent. So now I know that these two angles have to be congruent. Why? Well, it's not really a triangle congruence now. Just explain your reasoning. I already showed the triangles are congruent, right? And if the triangles are congruent, based on this congruency statement, angle S is congruent to what?
S.
S. Okay, angle Q is congruent to angle. Okay, side PQ is congruent to side RQ because they're corresponding parts, aren't they? Right? Does that make sense? So if the triangles are congruent, we know now there are got to be 6 relationships that are congruent. All the parts of each triangle have to be congruent to the corresponding parts in the other triangle. So here's the reason. The reason is, and you're going to call this from now on, this is a little weird, CPCTC. But what does that stand for? See if you can fill in the blanks. Corresponding parts of congruent triangles are congruent. That's it. So that's the important step that we add in 4-5 is CPCTC. Just don't forget what it stands for. Corresponding parts of congruent triangles. Listen, please. I can make this easy for you to kind of visualize and store this in your brain. Corresponding parts of congruent triangles are congruent. Well, all this work we did up here, all that work up here is really just goes there, right? We just showed that the triangles are congruent, right? Now we know that all the corresponding parts of those congruent triangles that we showed have to also be congruent. Okay? Let's do one more of those, and then it'll really stick. Okay. What about this guy? Now, first of all, we got to fix this PowerPoint. It's kind of, they made some mistakes, which we've gotten used to. That statement doesn't really make sense. Let's take this first statement up here. What does that symbol mean in the middle? Parallel. Okay, but as it's written, it doesn't make any sense. If I put an A and a B next to each other, what does that mean? AB means, say it again. Well, it's not, okay, it's related to it. It's almost, but it's something about the segment. The measure of. Okay, the measure of a segment is really the same thing as saying what? The length of the segment, yeah. Okay, so in order for this to be a geometric thing, I have to have a symbol over the endpoints. But if I just list the endpoints of the segment, that's talking about a number. It's a measure. It's a length. Well, the length of AB is parallel to the length of C. That makes no sense at all, right? Numbers can't be parallel. Numbers are equal. So what do I need to do to these? What symbols do I need to add so that this even makes sense? How do I mean, segments could be parallel, or lines could be parallel, something like that, right? But distances can't. So what symbol would I have to add to AB? Yeah, I could add a segment symbol over the top maybe, right? And a segment symbol to CD. Now that makes sense. Segment AB is parallel to segment CD, so I can show that by putting one arrow on each of those segments, right? Okay, same thing here. That would have to be segment BC is parallel to segment DA. Okay, now that helps. Now we added some important information. We're not given any congruence information here at all. And we need 3 congruencies. So somehow I've got to add 3 congruencies to this picture. If we want to prove, and once again, that segment AB is congruent to segment CD. Say it again. They share a line. Yeah, they share a side, I should say, right? These 2 triangles share a side. So they share side BD. So that's one congruent part of each triangle. What else? Okay, yeah, they give us this parallel situation again, right? If we know that side BC is parallel to side AD, then let's extend those. So I've got these two parallel lines, and here's my transversal. Okay, so there's my transversal. And so if you kind of think of this situation matching up with this picture, what are the angles that we're going to show are congruent? So this pink line is the transversal, right? The green lines correspond to the top and bottom sides. So what do you think? Which angles are important here? CBD. So that's this angle right here, which corresponds to that one, right? And what other one? BDA. So this angle right here corresponds to that angle. Does everybody see that? Stare at that for a second. Does everybody see that? Get those go together. And what would my reason be? Alternate interior angles there, right? Okay. So there's that one. Now what if we did something a little different here? What if we instead used oh, that's right. Oh, it's not. What if I use the other set of parallel lines? So those are the lines that kind of go like this, right? Corresponding to the left and right sides of the triangle. Same transversal though. Okay, so now we got to match up this chapter 3 picture with this chapter 4 picture. Okay, so Savannah, which angles now do you think we're going to be able to show are congruent? In this picture right here, which angles would be congruent? If I'll label them for you. Angles 1, 2, 3, 4. Oops, there's 4. 5, 6, 7, 8.
Just any at all?
Right. So I mean, there's a bunch of we could show. Give me one pair of congruent angles.
1 and 3.
1 and 3 would be okay. How about between this set and this set? So these are my parallel lines.
Oh, 3 and 5.
So 3 and 5 would be, sure, by alternate interior, right? Okay, and that's the one we want, isn't it? Because angle 3 would correspond to this angle up here, wouldn't it? Right, because here's my green lines and there's my pink line, right? So let's put 2. And 5 would be this angle right here. And what's my reason for that? You got it. What's the reason? What kind of relationship do they have? If parallel lines are cut by a transversal, then what are those?
Alternate interior.
Alternate interior angles are congruent, so alternate interior angle theorem. Good. Now, oh man, we're going to make it here. We got to just finish this up. So now we can show that these triangles are congruent by what? Yeah, ASA, right? Everybody see that? Okay, so the triangles, I'm going to have to make this really quick. The triangles are congruent by angle, side angle, right? Right? And so now we can show, hang on, hold on. Stay with me here for a second. We got to finish this. So now we can show that side AB is congruent to side CD by what? What's my reason? CPCTC. How is that? Oops. Okay, does that make sense?
Yeah.
Right, would you guys agree on this picture up here that sides AB and CD correspond because they're between the angles with no arcs and 2 arcs, right? So they're corresponding parts. Corresponding parts of congruent triangles, and that's what we showed up here, are congruent, right? Make sense? We're getting there? All right.
And make